In this video, we'll introduce the idea of how to find an amount of accumulation using the scenario of a Mars rover. The Spirit rover landed on Mars in 2004 and was active until 2010. It was powered by solar cells. As the rover traveled across the Martian surface, it kicked up dust, which accumulated on its solar cells. The amount of dust that it kicked up depended on the composition of the surface it was traveling over. A rockier surface would kick up less dust than a softer surface. Imagine that scientists are planning to send another rover to Mars and want to know how long it might last before too much dust accumulates on its solar panels. They have mapped out a 100-kilometer path for the rover to follow and have collected satellite data about the composition of the Martian surface at various points along the route using a LiDAR spectrometer. When the rover has accumulated 275 milligrams of sand on its solar cells, it won't be able to produce enough power to continue unless the Martian wind is able to blow the sand off the cells. If the rover travels along this path, does it risk accumulating too much dust? The first step in figuring out the total amount of dust that will accumulate is to identify the composition of the Martian surface at various points along the route. Here is a table that shows the composition of the Martian surface at 7 points along the rover's proposed route. And here is NASA's estimate of how much dust would accumulate on the solar cells per kilometer traveled for each type of surface composition. So, based on this, how can we figure out how much dust will accumulate across the rover's entire trip? The first thing to do is to break the path down into intervals. The next thing we need to do is to recognize that the data we have is a rate. For example, this 6 means that at a point 90 kilometers along the path, the dust is accumulating on the rover at a rate of 6 milligrams per kilometer. Now, this is just at a specific point along the path. But if we assume that each of these rates is constant over an interval, then that would mean to find the amount of dust that accumulates for each interval, we would multiply the change in position over that interval by the rate of accumulation. For example, over the interval from 90 to 100 kilometers, the rover travels 10 kilometers. If we're assuming that dust accumulates at a rate of 6 milligrams per kilometer, then the rover would have accumulated 60 milligrams of dust over that interval. And we could do this for each of the intervals. So, for the interval from 0 to 10 kilometers, we'd multiply the 10-kilometer change in position by a rate of 1 milligram per kilometer to get 10 milligrams of dust accumulating. And over the interval from 10 to 30 kilometers, we'd have a change in position of 20 kilometers multiplied by a rate of 1.5 milligrams per kilometer to get 30 milligrams of dust accumulating. For the interval from 30 to 50 kilometers, we'd get 40 milligrams, and then 50 milligrams, and then 70 milligrams. And if we added up all of this, we'd get a total of 260 milligrams of dust that have accumulated on the rover's solar panels. One thing you might have noticed is that we are always using the rate of dust accumulation at the beginning of each interval. For example, for the interval from 90 to 100 kilometers, we used a rate of 6 milligrams per kilometer for the entire interval, rather than a rate of 3.5 milligrams per kilometer. We could have done the entire calculation using the rates at the end of each interval instead of the beginning, and this would have given us a slightly different estimate over the total amount of dust that accumulates on the rover. Now, to summarize our general method, to make an estimation of the total amount that has been accumulated, we treat each interval as having a constant rate of dust accumulation. In the example, we always used the rate at the beginning of each interval, but we could also have used the rate at the end of each interval. Then, we find the amount of accumulation over the interval by multiplying the constant rate of change times the change in position. Then, to get the total amount of accumulated dust, we add up the amounts from each interval.